Hello and welcome to my YouTube channel. This is Ramani Online Mathematics. If today is your first time of visiting this channel, please try to subscribe and share. Here we just want to look at how to um, show that this is divisible by 6. And for us to do this, we want to use the PMI, the principle of mathematical induction, to do that. So let's start with this. The rule still holds. Rule number 1 says that if you want to do such a thing, first you say that let n to be equals to 1. So we say that n is equals to 1. So when n equals 1, we substitute n here to see whether it's divisible by 6, the number that we are going to get. So that will be 1 cube plus 5 to the power 1. This will give us 6. So with this, we can say that 6 is divisible by 6. So that one, we have no problem with that one. The next thing that we have to do is to say that n equals k. When n equals k, if I substitute here, just like I did it in the previous video, I'm going to have k cube plus 5k. Then you should let this one equals to 6m. Why are you equating it to 6m? Meaning that you are able to show that, yes, if I substitute 1 here, I'll get a number divisible by 6. That means this particular mathematical statement here is divisible by 6. So I can easily say that the whole of this equals to 6m. Is that all right? Where the m belongs to natural numbers. So when I put 2 here, it will be divisible by 6. If I put 100 as m, it will still be divisible by 6. Here, because I want to engage something or get something, let me make 5k the subject here. So that gives me 5k equals 6m minus k to the power 3. So I will name this one equation 1. And when we have to prove, that's why we say that we should let n to be equals to k plus 1. So I'm going to have, wherever I see n, I'll put k plus 1. I'll have k plus 1, k plus 5, k plus 1. Is that okay? So this is where I'm going to prove. You realize that here's k plus 1, here's k plus 1. So I can factorize that k plus 1 out. Then I have k plus 1 squared plus 5. So here, let me expand it. K plus 1. This will give us k squared plus 2k plus 1. Then plus this 5. Okay. 1 plus 5 is 6. So I'm going to have k plus 1, k plus k squared plus 2k plus 6. Because 1 plus 5 is 6. The idea is that I want to get 5k in this so that I'll replace it by 6m minus k cube. So let me expand this one again, which will give me k cube plus 2k squared plus 6k plus k squared plus 2k plus 6. So this gives us k cube plus 2k squared. Now 6k, 2k squared, 2k squared. So here it becomes 3k squared. Plus, because I need 5k, this and this, if I add it to be 8k, so I can write it as 5k plus 3k plus 6. So that the 5k can be replaced by 6m minus k squared. So I have k cube plus 3k squared plus 6m minus k cube plus 3k plus 6. This is opposite to this, so they will cancel out, leaving 3k squared plus 6m plus 3k plus 6. What happened here is that because we want number a statement that is divisible by 6, let me factorize 6 out. So that I have half k squared. If I factorize out, you see, if I multiply this by this, it will give me this plus m plus half k plus 1. And I said that all this, let's represent it by b. Okay, I have 6b, where the b belongs to natural number. So therefore, since this b is a natural number, any natural number I put here, if I put 5, 6, 8, 10 here, by 6, because it's multiplied by 6, it is divisible by what? 6. Is that okay? So you conclude, therefore, by p mi n cube plus 5n is divisible by 6. Thank you very much for watching.